Download this code from codegive.com, link in the description below. Certainly. The problem shortest subarray with sum at least k, leetcode 862, is an interesting one that combines concepts from prefix sums and sliding window techniques. Let's go through the problem statement, the approach to solving it, and a complete Python code example. Problem statement. Given an integer array A and an integer k, you need to find the length of the shortest non-empty subarray of A with a sum of at least k. If there is no such subarray, return -1. Example. Consider the following example. Input. Output. Explanation. The shortest subarray with a sum at least 3 is 2, 1, which has a length of 2. Approach. 1. Prefix sums. Create an array of prefix sums where each element at index I represents the sum of the first I elements of the array A. 2. Monotonic queue. Use a deque, double-ended queue, to keep track of the indices of the prefix sums. This will help in quickly finding the shortest subarray that meets the condition. The deque will always maintain indices in increasing order of their corresponding prefix sums. 3. Iterate through prefix sums. For each prefix sum, check if there exists a previous prefix sum such that the difference between the two sums is at least k. If it exists, calculate the length of the subarray and update the result if it's the smallest found. 4. Maintain the deque. Ensure that the deque only contains indices of prefix sums that are relevant for the current index being considered. Python code example. Here's how you can implement the above approach in Python. Explanation of the code. 1. Prefix sum calculation. We create a prefix underscore sum array where prefix underscore sum I is the sum of the first I elements of A. 2. Deque for indices. We maintain a deque that helps us find the shortest subarray. For each prefix sum, we check if the current sum minus the sum at the front of the deque is at least k. If it is, we calculate the length of the subarray and update min_length. 3. Maintaining the monotonicity. Before adding the current index to the deque, we ensure that we remove all indices from the back of the deque whose corresponding prefix sums are greater than or equal to the current prefix sum. This keeps the deque ordered in a way that allows us to find valid subarrays quickly. 4. Final result. Finally, we check if min_length was updated from its initial value. If not, we return -1. Complexity analysis. Time complexity, O, n, where n is the length of the input array A. Each index is pushed and popped from the deque at most once. Space complexity, O, n, for the prefix sum array and deque. This approach is efficient and should work well for large inputs, making it an excellent solution for this problem. Certainly. The problem shortest subarray with sum at least k from leetcode, problem 862, is a classic algorithmic challenge that involves finding the shortest contiguous subarray in a given list of integers such that the sum of the elements in that subarray is at least \k. Problem statement. Given an array of integers a and an integer k, you need to find the length of the shortest contiguous subarray, if it exists, with a sum of at least k. If there is no such subarray, return -1. Approach. To solve this problem efficiently, we can use a combination of prefix sums and a monotonistic, double-ended queue. 1. Prefix sum. First, we compute the prefix sums of the array. The prefix sum at index I represents the sum of the elements from the start of the array to index I. 2. Monotonic queue. We maintain a deque that stores the indices of the prefix sums. This allows us to efficiently find the smallest subarray sum that meets the requirement. Steps. 1. Compute the prefix sums. 2. Iterate over each prefix sum. For each prefix sum, check if there exists a previous prefix sum such that the difference is at least \k. If such a previous prefix sum exists, update the minimum length of the subarray. 3. Maintain the deque in a way that it always contains indices of prefix sums in increasing order. Code implementation. Here's how you can implement this in Python. Explanation of the code. Computing prefix sums, we build an array prefix underscore sum that holds cumulative sums. The \i_th element of prefix underscore sum contains the sum of the first \i_ elements of the array \a_. Using deque. The deque is used to maintain indices of the prefix sums in a way that helps us find the shortest subarray efficiently. We check whether the current prefix sum minus the prefix sum at the front of the deque is at least \k_. If it is, we update the minimum length and pop from the front of the deque. To maintain the order in the deque, we remove elements from the back if the current prefix sum is less than or equal to the prefix sums represented by indices at the back of the deque. Complexity. Time complexity, \o, n, where \n is the length of the input array \a_. Each index is added and removed from the deque at most once. Space complexity, \o, n, for the prefix sums and the deque. This approach is efficient and works well for large arrays, making it a suitable solution for the problem.